All right, so this is kind of the second part. The little simulation, again, was to kind of serve as an introduction to how do we draw ionic compounds. So we're going to go through just kind of the 5 steps of how you draw Lewis structures for ionic compounds. So these are steps that you're going to want to have written down. Again, this will be uploaded to YouTube. You have a copy of these notes on Schoology if you miss anything. But step number 1 is determine valence electrons. So for any kind of bonding, you're going to be given 2 elements. And if it's ionic, it's going to be a metal and a nonmetal. And so step number 1 is how many valence electrons are there? And that was something that you were doing in the simulation just now. Once you know the number of valence electrons, step number 2 is put the dots on. So aluminum has 3 valence electrons, put your 3 dots on. Fluorine has 7 valence electrons, put your dots on. So step 2 is put your dots on. Step 3 is transfer the electrons using an arrow. Now there is something to keep in mind, that the arrows always go from the metal to the non-metal. But if you just make it a habit to always write the metal first, then your arrows just always go left to right. And I find that to be a much better solution of just always write your metal first. So then everything else just kind of lines up after that. As opposed to remembering that, oh yeah, it has to go from the metal to the non-metal. I don't know, it just seems easier to just always write your metal first. But then use an arrow to show the transfer and then write down the charges. So step number 3 has kind of a lot in it, in the transfer. So we are symbolizing the transfer with an arrow, but then as a result of the transfer, charges develop. And so you have to write in what those charges are. Step number 4 is kind of if it's needed. So if an ion didn't lose all of the electrons, didn't lose all the dots, so you got dots left over, or an atom didn't gain to get up to 8, then you need to add more ions until it works. And it will always work. Assuming that you're drawing things correctly, it will always work. So you figure out valence electrons, put your dots on, transfer the electrons with an arrow, and then you need to add ions accordingly until all atoms have lost and all atoms have gained the appropriate amount. And we're going to see a couple of examples here right now. So let's look at KCl. Let me erase my drawings. So we got potassium and chlorine. So those are our 2 elements. So you would write them down. If you don't know the symbols, well, the symbols are right there. But you can always look on the periodic table. So the first step is how many valence electrons. So you need to find potassium, K, on the periodic table. It's in group 1, so it has 1 dot. Chlorine is in group 7, so it's going to have 7 electrons. And so we put our dots on, so potassium just has the 1, and chlorine putting 1 dot on a side until every side has 2, or until every side has 1. We end up with our 7 dots. And so you can see how this 1 electron from potassium, how it has a perfect little spot to go. And so that's where we do step 3, which is transfer. So we are using an arrow to symbolize the transfer. As a result, potassium becomes +1 because it just lost a negative charge. And chlorine becomes negative because it just gained a negative charge. And in this situation, I don't need to add any more ions. So step number 4, I can kind of ignore because potassium has lost all of its electrons and chlorine has gained up to 8. So I have no need to add more electrons. So if this were a test question, this is what I'm looking for as an answer. Let's look at another example. So we have barium fluoride, and my animations are off, so that's fun. So barium has 2 dots. You can't quite see it, but there was a dot right here, wrong color, a dot right here, and a dot right there. And fluorine has 7. And so fluorine can only accept 1 electron. And so this is where step 4 comes into play, because I have this little extra dot on the barium. And so I'm adding an additional fluorine so that that second electron can be transferred over. And so, as a result of the transfer, barium just lost 2 electrons, so it becomes +2, and each fluorine has gained 1, so each fluorine is -1. I don't need to add anything else because the barium has lost all of its electrons and the fluorine has gained all of its electrons. Some additional notes just about ionic. You don't necessarily need to write this down, but it's just atoms are not sharing. So sharing, yesterday we talked about, was for covalent compounds. What's happening is electrons are being transferred in ionic. This is why an arrow is the appropriate symbol to use for transfer. The second thing that's always forgotten is you have to write the charges down. It's one of the things you get going and you kind of forget to write the charges. So that's kind of a must, that you don't want to forget that. Now you might have noticed I said that there were 5 steps to drawing ionic compounds, but I've only talked about 4. It's because the 5th one is not really a step, it's really a check. When you draw these things, how do you know that they're correct? Well, it's because the charges will equal 0. After you do the transfer and you write down all the prescriptive charges, if you add all the charges up and it equals 0, then that should give you a pretty good likelihood that you did it correctly. Like, let's go back and look at the previous example. +2 minus 1 minus 1 equals 0. So step number 5 is just, it's a way that you can determine whether or not your drawing is correct. Is that your charges must equal 0.